Hello everyone. Today we'll talk about how to define variables, primitive types, wrapper classes, and a little bit about order, packaging, scope, and constructors. Okay, so let's create a simple Hello World program one more time like we did last time, but this time we're going to use idea. Let's create the project. So here we define the location. So let's say here, let's give it a name, let it be 4. And here we define which JDK we're going to use. So let's select 17. Add sample code. That's actually auto-generated main. So let's leave it there. And generate code with onboarding tips. Depends whether you want it or not, but you can actually try that. And advanced settings, it will give us about the group ID and artifact. That's part of the packaging. So you can change it if you want to. And about the build systems, you can choose either IntelliJ Maven Gradle, but let's just keep this Maven for now. Maven is one of the dependency managers. They also help for the building and packaging our application. And here we're choosing the Java. Java is by default, but you can actually choose any of those. Let's create a project. Here it is, our main class is hello world. So if it's folded like this, you can unfold it and just try to run it. There you go, our application is up and running. So now, as you already paid attention, and we talked about it last time as well, so the class name and the file name should actually match. So if we say and we change it, it will show it as an error and it says why is it. Should be declared in a file name main too. So since file name is main, the class name should be the same. So there are a couple of rules for those, and each file can contain only one public class, meaning, so now it's working. But if you try to define another class here, let's say second, it will say should be declared in a file name second Java instead of within this file. All right. So, but actually we can create second class here, although it's not recommended from my view myself, to be honest. So I would prefer to create a class in a separate Java file instead of trying to create several classes in a one file itself. So, but it is possible as long as there is only one public class. Okay, and so we talked about the file name match, and there is something called the entry point class that will probably going to be next, maybe not next topic, but it's also important to know that if the class is the entry point, then it has to have a main method like this, public static, where our application may contain several classes, but one of them is responsible for running it, and this class will actually use the other classes at some point. Now let's talk about the primitive types. So there are several primitive types. You can Google them again, but here is the, if it's visible enough. Okay. So the byte, short, int, long, float, double, char, string, and boolean. Let's just try to create one of those. There you go. So we define, we give a type of the variable, name, also known as identifier, and the value. Like this, we can try to create all of these types, primitive types, and they actually have minimum and maximum value. You can also search those. So byte is starts with minus 128 up to 128. And there are short, int, long, float, double, and for all of these, there are minimum, maximum values. And I'll show you one of them in a second. So let's create another one. It's very important to know that if we specifically give the value initialization in the first point, so this value is actually automatically initialized as int, and then the variable name as a reference points to this value. So that means if I try to give it the value like this, it says it's not possible because this value will automatically identify it as a double, and it cannot actually convert automatically to float. So in order to resolve this, we have to specify that this is a float value, and we're actually adding f there. You can actually put like this as well. Okay. The same actually applies for example, if we try to create an int variable, but give it a floating point number, then it will say it's not possible, right? So these things we have to keep in mind. Now, let's talk about wrapper classes. So each of these types has a wrapper class. They can have, let's say, let's leave it as that. So like this, pretty much the same way we can initialize it. Let's define it as h for now. Now, what's the difference between this byte and this byte? This byte actually gives you several methods. So if you type h and the name of the variable and dot, as you can see, there are quite a lot of built-in methods that it gives. And most likely you will come across is toString very often. And if you try to let's say cast from other types, there is already methods for that. So int value, long value, short value, and also equals compared to that we learn about when we talk about the classes. Okay. Now, when we're talking about the values, some values may actually, let's say, about 1,000, right? So sometimes it's difficult to see whether it's 1,000 or some another value. So for that reason, we can actually use underscore. So now, as you can see, it's actually taking this value, and it's actually more readable compared to without this underscore. And we can use underscore, but as long as it's not in the beginning of the value or at the end of the value. Same applies for the floating point numbers. So we can use this, but if we say before or at the end of the dot, it will give us an error. Okay, now it's time to talk about how do we actually define these identifiers. So these identifiers cannot be a reserved keyword, meaning Java has its own keywords, like as you can see, the void, main, and class. Some of them is actually possible to use, but it's not actually recommended. It's just cumbersome and sometimes difficult to identify which is actually the keyword or which is the identifier. Then here is the list of the the Java reserved keywords, and it's better not to use any of them as an identifier or the name of the variable or method. But the general rule is that identifiers must begin with a letter, a currency symbol, or underscore symbol. You know about currency symbols, so meaning we can say ID underscore. Let's just give the value to see whether it's going to give us an error or not. As you can see, that means we can actually create a keyword like this with a starting underscore, same as starting currency symbol. It's possible, although it's not much readable, but it depends on the program all the time. So depends on your project. Maybe it's useful for you in some cases. Then it also can contain the numbers, only if it's not in the beginning of the identifier. As you can see, that will give us an error. And a single underscore is not allowed as an identifier. That means we can actually specify to give it a 2 underscore. It looks bizarre, but still allowed by the compiler. Okay. So now we know several rules about how to identify give it a name for the variables. Same applies for the method names, as you can see in here, and the class names. Now we know how to create and declare variables. It's probably time to talk about methods. So let's create another one method just to see how can we actually create another method. So pretty much the same as the above one. We will give access modifier. We will talk about it later when we go to the methods in detail, and we have to give a return value. So it can be one of those or void, meaning this method doesn't return anything. Then we give it a name, say talk, then this parenthesis. Within we can actually pass some variables to just process this method, but if you don't want it, we don't have to. Now print, let's say, talk to me, and let's try to call it. So I'm just going to remove those because we don't need it at the moment. As you can see, it says it's not possible to call. Why? There you go, non-static method. That means in order to be able to call this method, we have to create a new, let's say, instance of this class specifically. And in order to do that, you can just give the name, let's say this one, and new keyword, main, and then only after that we can call this method. There you go. But now, if you have questions like, what if you want to call this method even without creating, instantiating this class itself? That's also possible, and for that we use the keyword static. That means this method now belongs to the class itself, not to the instance. And yes, we'll talk about it later again, but for now, this is just an example that we can actually call the method like this. In a similar way, we can just call it this way as well with the name, because since we are within this class, we don't have to specify the name of the class. But when we are talking about the other classes and using and calling their methods from outside it, then we have to specify the class. Sorry for the noise. Now it's calling twice. Okay, so we're good with that. Now it's probably time to talk about a little bit about packaging. So the packaging is basically the hierarchy of folders, and this the Java way, and mostly pretty much all the programming languages use packaging to organize the files. That means let's create another class, but this time let's make sure we are creating a package first, different package. Here it says org example. No, I wanted, let's say under example, home. Then we see another package, meaning another folder. Here we can create a class human. There you go. And as a structure, it will look pretty much like this. Let me just make this list, okay? And the extension for source. Here is our application main Java org example. Now you see the location of org example and home. That's all the packaging means. It's just the way to organize Java files. Now, if we just, let's say, define a method here as well, and let's make it static again, to be able to call without instantiating the class itself. We say we don't want to return any value. And we want to call this class method from our application. So the name of the class is human. The method name is talk. And as you can see, this is one of the reasons why we want to use the integrated development environments. That actually helps for importing, packaging. It has lots of benefits actually. So in order to be able to call this human class, we have to import it. Without this line, our code will not work. So we have to import it. And this is the order. This is the ordinary order of the class. So first is the package where the file is located. Second is import, which classes we want to use in this specific class. And then we define a class itself. So what I say when I say an order, that means if I just take this and put it input first, it will not work. So if these import and packaging exists, then they have to follow this specific order. Okay, so since we just touched base about importing, there is a star wildcard as well. That means let's import all the classes within this folder, within this package. So from now on, I'll just talk about folders as a packaging because this is the terminology that we should use. Now, what I mean is, if I create another class here, let's say animal, and let's create another method here, let's say talk. They do talk in their way. I'm just joking. Let's say meow. Let's say this is a cat. Now I can actually, so I can actually call this method straight away. Because we already imported it. This is much more better instead of just saying import human first and then import example animal. This would have been a better way. It depends how many classes you have under the package, because obviously if there are like 100 classes within this package, you don't want to import all of them. Obviously, you don't want to do that. But if you know there are only 2 classes within the package, it's just more readable. Just put the star here and import all of them. Now, this is very tricky point, is that it only imports the classes within this package, but not under other packages within this package. Meaning, if I create another package under home, let's say, let's just pay package 2. It doesn't matter. Package 2. And then if I create another class, let's say shape, and it has another public static void. Yeah, what's the name of this method now? And let's say calculate the, say, calc, short for calculate, and it should, let's say, it does return calculation is in progress. Let's say that this doesn't matter, because all we want to just make sure that this shape we cannot access this shape clip unless we import it. So this import itself will not work anymore, because there is another package name under the home. So only the classes within this package will be imported when you use the wildcard. There are several other rules as well, like when there is the same class name within the several packages, then how do we resolve this? So in that kind of situations, it's actually better to specifically mention which class you want to import when you're using. Also, it's possible to call them by the package name as well. So let's say I want to specifically call human. This is only required when there are several class names with the same name and under the different packages. Why same name under different packages? Because you cannot actually create same class under the same package. So if I say shape, says already exists. The same name and the same package, it's not possible. And yes, it's a good practice to make class names unique. It's better to just make them unique all over your application. It doesn't matter which package it's better to just make it unique. Now, since we know now how to import, how to package our classes, it's probably time to talk about this scope. What is scope? Scope is a portion of code where a variable can be accessed. Meaning, so if I say I want to define this variable I, this I variable is under the scope of this area, let's say, this portion of code. This I is not accessible here, not accessible there. It only belongs to this curly braces. And out of this space, it's already called out of scope. But there are several ways of creating and using the variables, and we can actually identify these variables within the class itself. And if, let's define one of them first. So let's make it string this time. Let's not give a value. So now here, this one we can actually access, right? No, we cannot. Why? Again, we haven't created instantiated the class. Now, if you create the name, only then we can actually access the first name and give it a value. Give it a, let's say, John. Doesn't matter. Now, again, like we just talked about it, we can make it static, and now you can access it just by using the class name. Static. There you go. So later we'll talk about classes in detail, but for now you can see that static fields belong to the class itself, same as static methods. So when you instantiate the class, this variable points to the one of the instance of this class. But these fields belongs to the class itself. So that's why you can call them and use them without creating instantiating this class. Now, let's when we're talking about scopes, right? So this one's already in the scope within this class. Now, there are several rules for scoping. So when we talk about local variables, they are in scope from declaration to the end of the block. Just like I said, if I create local variable, this is the local variable within the method, and these are within the scope, within these curly braces. Outside, they're not. Now, method parameters, like here we have args, so they are also in scope for the duration of this method, again within these curly braces. So what I mean is, if I, for example, create another code block, it's possible, but probably ugly to write this code. But anyways, maybe useful in some other circumstances. So if I say int j9, then I will not be able to access that j. Why? Because it's out of scope. It's out of these curly braces. It's going to say cannot resolve symbol j. But I still in the scope because it's defined here. Instance variables. Instance variable is any variable that's without static within the class, this one, not within these methods. And a good example, this is actually one of the, not written, probably it's already written in the standards of Java, but so the variables actually defined first and then the methods after. And I would actually, yeah, let's keep it that way. So these instance variables are in scope from declaration until the object is eligible for garbage collection, meaning if you're defining a new instance of this class, so once this object's out of scope, all its instance variables are out of scope as well. And what about the class variables, the ones that actually has a static keyword on them? They're in scope from declaration until the program ends, meaning once our application has an entry point and we have imported that class, and so from that point of that variables are in scope, but once the application has ended, then they're out of scope as well. That's pretty much, yes, about the constructors. So what are the constructors? Constructors are basically the specific methods that helps to initialize our classes. So let's say if I create one constructor here, so it doesn't have a return value because return value is itself the class instance. So, but it has to match the class name. So as you can see, it's pretty much a method with the class name without return value. Okay, so here we can set value. Now this time, let's say Umar. Now, if we try to access the first name, well, let's make it instance variable. Then we can see the Umar value is there already because the constructor is actually run as soon as we created an instance. When we talk about this one, we can actually avoid this and try to print it. Yes, that's about the instance and static variables initialization, but this is one of the things I have to probably mention as well, is that if you don't have a value straight away, it will take the default value. For reference variables, it's null. For primitive values, it's the representing null value. So if I have I here and double D, then those values will have corresponding null value. I will be just 0, the same as D. Okay, but we cannot do the same for local variables. So once you define, you have to give it a value. That means you cannot just call L, because it's going to say it's not initialized. Now, what I was talking about, yeah, scope is probably done already. Yes, constructors. There may be several constructors, but we'll talk about it when we touch base on the classes. So again, we talked about primitive types for Apple classes, how to define variables, scope, very important when we're using the different variables, and a little bit about packaging, and that's pretty much yes. That's all from me, and thank you very much.